Hi, subscribe to this channel. Go to this red subscribe and click. And you also see this bell shape. So click on this and select all. This means you would be getting notification of all videos uploaded on this channel. Cheers.
We will start doing something which is called calculus of trigonometric functions. Yeah. So we have to today do uh, calculus of. Do you have some idea of this?
Calculus?
Of trigonometric functions?
I think so. Like as in differentiating them.
Yeah.
Yeah, I do know like the basic ones.
Okay. So what we will see is, in fact, let me take another color maybe. So if you see if y is equal to sine x, y is equal to sine x. Do you know what is dy upon dx or y bar?
Uh, that is cos x.
Good. That is cos x. That is cos x. So let me write it a little more clearer. So it is cos x. Yeah. Okay. And what about if y is, let me take another color. If Control Z. Yeah. And what if y is cos x? If y is equal to cos x. So do you know what is y bar?
Negative sine x.
Good. It is minus sine x. So this is a little difference between them. And what about if let me take now another color. If y sine cos and one thing is tan. So what is y bar? Do you know that?
Is it 1 over cos squared x?
Yeah, good. It is 1 over cos square x. And it is also called in another form, it is called secant squared. Do you know what is secant is?
No.
That normally it is not in your syllabus, but if you see, and let me take a red color maybe. So 1 over sine x, 1 over cos x, and then 1 over tan x. So 1 over sine is called cosecant. It is called cosecant x. Another name of this, or not, nothing very special. Just they have 1 over sine x is called cosecant x. And it is called secant x, secant 1 over cos x. And this
Mm.
is called cotangent. Yeah. So this is called cotangent x. Cotangent x. But even if you don't know, that's okay. Yeah. It's no problem. But if you would have taken math specialist, uh, they would teach it. Otherwise, knowing just these three formulae is more than enough. Yeah.
Yeah.
Okay. Um, we would do few questions first, and then I would move to 8R question. Um, that's the same thing like a product rule and something like so let's do, for example, let me move to the, and I take and we do one question. So in the question, y is equal to uh, cos of 2x, 2x, or let's change it a little. It says cos is equal to 5x, 5x plus 3. Can you differentiate it?
Yeah. So So it'll equal -5 sine 5x plus 3.
Yeah, so y bar would be negative sine 5x plus 3, and then we would differentiate what's in the bracket, so it would be,
Yeah,
and it would come earlier, so we can write it now like this. That's
yeah.
good. Let's me ask you a question, and then we would do, and it is because it's a 8R question of 2017. Yeah, so
Okay.
let me ask you and see that. So it is a part of both. So first of all is different if y is equal to, so this is a question, y is equal to 2x sine 3x. Yeah, so you have
Okay.
to differentiate, you have to find y bar. First is this question, and this had a mark, this was a 2 marks question in 2017. Yeah, this is a 2017 math methods. Can you let me know what is the answer, please?
Sure.
Solve it and
Yeah, I'll do that. I think I got it. Yeah.
yeah.
So
So
is it
yeah,
yeah. So is it 6x sine 3x
sorry,
plus 6x sine 3x
6x sine 3x.
plus 2 sine 3x. Oh, sorry,
No, no.
6x cos 3x. Sorry,
Yeah,
sorry.
yeah, yeah. That was a 6x cos 3x. And
Yeah. Plus 2 sine 3x.
yeah, that's correct. So we know it's u into v. So we first
Yeah.
differentiate with respect to x. So it will become 2 sine 3x. And then plus we have now we differentiate the other. So it would be 2x times, and sine 3x would become cos, it would become cos 3x and time 3 because, so this would become 2 sine 3x, just a minute, 3x plus 6x cos 3x. Yeah, so that's your answer also. Is it? Hello?
Yeah.
That's your answer, yeah?
Yeah.
Okay, so this was a part A of the question. So this was a part A. Let's look at the part B. Um, part B says show. It says show um, x cos 3x dx is equal to, so you have to now do an integration. Yeah,
Yeah.
this is 3x sine 3x plus cos 3x over 9 plus c. And this had also 3 marks. So the question, this question had also, let me write 3 marks in, and this was also, this is in the 2017 8R.
Yeah. Yeah.
So they have already given you the answer, but can you attempt it?
Okay. Yeah, sorry.
Let me see whether it's a calculator assumed or it was it. Uh, I'm not able to see whether it's calculator assumed or what is it's a CF. So
Yeah.
CF,
Uh,
what is meant by CF?
oh, I'm not sure.
Mhm.
Calculator free, I think, must be.
Yeah. So it's a
Yeah.
calculator free. Have you covered this topic at the moment?
No, I'm not sure how to do this. No, yeah, I I'm not sure.
Oh, okay. I think we covered something which was at the moment in advance, but we would do that. So because it's something. So let's first of all look at some of the formulas. Yeah. Um,
Mm-hmm.
so if you have a integration of cos x dx, do you know what is this thing equal to?
Is equal to sine x.
Yeah, it is equal to sine x plus c.
I plus c.
Yeah, and
Yeah.
then there is something which we also see. It says if it is fx, yeah, there is a
Mhm.
function which is being multiplied with and it is a derivative into
Yeah.
into cos x. Yeah,
Mhm.
sorry, it's a function and here also a function. So f bar
Yeah.
x into cos fx dx. So what would be the answer? So it's from there, just looking at comparing these two. So you should compare this with this. So,
Yeah.
so can you
So,
just guess what would be the answer?
um, no, I'm not sure at all. No.
If you look at here in the first, I'm saying this one, let me take a red color. So the x, there is an x and x, cos x is sine x. And here,
Yeah.
and therefore, what is the derivative of x?
One.
So actually, we are multiplying it with 1.
Okay.
So can you now guess what is answer of the second formula?
So is it uh fx sine
It would be
fx?
sine fx
Oh, okay.
plus c.
Oh yeah. Sorry. Yeah. Yeah.
And there would not be something.
Yeah.
And do you know, let me say, now I write in yellow maybe. Do you know what is the integration of sine x?
Uh, would be negative cos x
And don't forget to write c.
plus
Yeah.
c.
And now I would again ask you something which is similar. So we have a f bar x sine fx dx. So what would be the answer?
So it'd be negative cos fx plus c.
Yeah, that's good. Minus cos fx plus c. That's good. Yeah. So
Mm.
you understand that. Okay. Um, so that's something which we have seen. And the question which is a little tricky more than that. Why? Because it does not have because cos of 3x is not something which is in the x. So this is a somewhat a little tricky question, which is maybe things which we will cover later. It is actually u into v formula, but I would just at the moment do few question next and then we attempt this like the other question. Yeah.
Yeah.
Okay. Um, let's say that you have a question which says, okay, um, uh, we have to find antiderivative of, mm, okay, let's do one or two questions and then we will be, let me write a question for you. If it is a question is uh, 3 sine x dx, I suppose it's a easy question. So can you say what is the answer?
The answer would be what it just -3 cos x
Negative, yeah, negative 3 cos x plus,
plus c.
that's good. And
Yeah.
if we have just a little more question like a 15 cos of 5x dx, can you let me know what is the answer?
Would it be 3 sine 5x?
Sorry,
Would it be 3 sine 5x?
how?
Um, because I thought that when you differentiate it, the 5x becomes 5, and you times it by the
Yeah, so actually
yeah
you are doing like this 3 and then you put 5 times cos of 5x dx. And now
yeah
if you look at here, this is your fx
mm,
and this is your f bar x.
mm,
Yeah, so this
mm,
comes out to be, let me again take 3 cos of 5x. Sorry, not cos, rather sine. Let me just rub it.
yeah
So this thing comes out to be um, yeah, 3, and this thing is sine x,
mm,
sine 5x plus c. Yeah, that's good. Okay. Um, we try to make it a little difficult now because we are going good, so we take it a little difficult. We have a formula which you have to now do cos raised to the power 4x uh, and sin x dx. Can you integrate that?
um uh no, I'm not sure how to do the power of
Okay, let's look at the actual formula which we have, or rather I write it again. So we have something like f bar x cos fx. So we had a formula which said that was f bar x sine fx. Yeah,
yeah
dx. What was the answer?
cos negative cos fx plus c.
Sorry,
Negative cos fx plus c.
negative cos fx plus c. My negative cos. So that was the, or I just, you can remove that bracket also, but it's okay. So that's the formula, yeah.
Yeah.
Now we see something like that. This is our, um, let's look at here and we try to, I do it first with some more easier way and then let's say coming to this question and let u is equal to cos x. Yeah,
Mm-hmm.
do you, what would be u bar?
U bar would be negative sine x.
Y- yeah, okay.
Mm-hmm.
And u bar, so u du upon dx. So you have said, okay, let me just rub it. This is actually du upon dx.
Mm-hmm.
Yeah? Okay,
Mm-hmm.
let's do that there. And what does it means? And let's do that and put it there. So this will become what it would cause x would become. So here what we have,
Oh,
yeah, this would become,
that would become uh
no,
sine
no, no, no,
the
no.
power.
We are
No?
just putting this u.
Oh, u. Sorry, u to the power of 4.
So it becomes u to the power of 4.
Mm.
And what is du? Sine x?
Is yeah, negative sine x.
No, no. So what
Oh,
would,
sorry.
so instead of sine x, what should I write?
Uh, mm, negative du upon dx.
Good, good. And then we have the dx.
Yeah.
Any question till now?
No.
So this dx and this dx get cancelled. Yeah?
Yeah.
Okay. So what is now we have? So this thing becomes u 4 du. And I take minus out. Can you
Mm-hmm.
let me know what is the answer of this thing?
Um, it would
It's
be. Oh, it be 5u over 5
why 5? If x dx integration, what is that? This is x square over 2 plus c.
2
Yeah?
plus, yeah, yeah,
What if it is x raised to the power n dx?
goes x n plus 1 over n plus 1 plus c.
So that's the same thing.
Yeah,
So what would be this thing equal to? Minus? Minus because the minus is outside.
yeah. It would be u to the power of 5 over 5 uh, times u.
Y times u. Nowhere we are timing u. Where are we timing u in this or x? This is the
Oh,
same formula. X and instead of x we have u. So if it is, let me ask you from here, let me take this. If it
yeah.
is x to the power of 5 dx, what is the answer?
X to the power of 6 over 6 plus c.
So is any multiplication of x additionally required?
No.
So this is minus u. So instead of x, we have a u. Instead of 5, we had a 4. So now confirm me the answer.
Uh, I'm not sure what to do with the du.
Why? Instead of dx, it's now the variable on the which it's differentiating is dx. Otherwise, you would not have been able. This is simple.
So plus c. Oh, sorry.
It's
Yeah, okay.
it's a just change of the variable. Otherwise, it's the same thing.
Okay, yeah.
Is it clear?
Yeah, it is now, yeah. I
So
understand.
so we had this formula. Let me zoom it a little down. We had the question which was this one. Let me highlight it. You see here, and we found it. This is to be the answer. So what is the answer then? Because we converted it. Instead of u, what should I write?
You should write cos x.
Cos x to the power of 5. So it becomes cos over 5 plus c. Do
Yeah,
you have some question with respect to this question?
yeah. So, so why is it that the sine x isn't in the answer?
It is not in the answer because we saw this is our fx and this is our fx bar. So question was, if you have a question like this, fx to the power of n dot f bar x dx. So what is the answer? It is fn plus 1 into x over n plus 1 plus c. Do you remember this formula or you have forgotten it?
I think I remember it, yeah.
So it's the same thing. Let me just zoom it a little down so that you understand. So what is fx in this case with comparing it with our original formula or
So
original question
fx is cos 4x
cos 4x. What is f bar x?
sine x.
No, it should have been
Oh,
minus because cos x, so it should be a minus. Therefore, you have to have a minus outside. It you could have solved it very instead of putting this all replacement, you would have done it directly. Do you understand that? So cos x,
yeah, I think so.
the
Yeah,
cos x has a derivative minus sine x, and therefore it you could have written this answer directly.
yeah,
Have you understood now or no?
yeah, I do, yeah. Can we do one more?
Yeah, certainly. Let me give you a another question which is a little tricky than that. So let's do another question. And the question says it is 3, and now you should attempt it. Minus sine raised to the power of 3, 4x. So I put it in a bracket, and then is a cos 4x dx. What do you think what is fx here?
fx is 3 sine 3 4x.
Yeah, is it 3?
Oh,
Is
so
it
to the power of 3.
oh,
Yeah,
that the power and this 3? Okay. And now, can you answer this question, please?
sure. Uh, give me a sec, sorry. Is it? I think I got it, but I'm not sure.
No worries, no worries. That's good that you are able to. Yeah.
Yeah.
Yeah, what is the answer?
So I think I got Sorry, give me a sec. Sorry. Okay, so is it is the answer 3/16 times sine to the power of 4x?
Yeah, we can look at it. I have to do it in fact, but I think you are right
Okay.
because
Okay.
we see this is fx and
Yeah.
sine 4x. If you differentiate, so it would become. So I just write like this: fx is equal to sine 4x, and
Yeah.
f bar x would be cos 4x into 4. Yeah.
Yeah.
So it means if for this question, you will have to convert it in a form that you say, okay, so this becomes sine cube 4x, yeah,
Yeah.
times 4 cos 4x because you want to do that dx. And because you have put a 4 extra, so you divide it by 4. So far, so good.
Yeah.
And then it becomes 3 over 4 times sine What is fx, and it is so this is a f bar x, yeah? So what would this
Yeah.
become then?
It will become to the power of 4.
Yeah, that becomes to the power of 4. So it becomes sine 4x over 4 plus c. Yeah. And then becomes this is equal to 3 over 16 sine to the power of 4x plus c. That, I
Yeah.
suppose that was your answer. I couldn't.
Yeah. That was mine. Yeah.
Yeah, that's good. That's good. So we are able to see some. We are able to do some things. And okay. Uh, so I do not know. We have in fact moved from 7A to another exercise 7B. So
Yeah.
we are actually doing at the moment 7B. Do you want that I should come back to 7A, or you want that we do some more questions like this, or let's go back to 7.
Yeah. Can we do some more 7A?
Yeah, yeah, we move back to
Yeah.
7A instead of, okay. Um, and then at the end we would try to do something more. Okay. Um, so let's do, it says a product rule. It's so 7A exercise is related to derivatives, yeah?
Yeah.
It's not the entire derivative, rather it's concerned with the derivative. You can look at the book. Do you have a book with you?
Yes.
So let's open exercise 7A, and then we would do together some of the questions of the exercise.
Sure.
Yeah. So which question you like to do?
Um. Can we do? Can we do the sum of like of the question 55 to 58?
55 to 58. Okay.
Yeah.
Determine the gradient of each of the following at the given point. Yeah. This
Yeah.
is the question. I would love that before we attempt it, we do anything from 19 to 28, 19 to 22 maybe.
Okay.
Do
I don't mind. Yeah.
Yeah, so that you understand which one from 19 to 22 we should attempt, and then we would move to 55.
Uh. We can do 22.
Okay,
22. Yeah.
so let's do we try to do the question number 22. And what is it? Y is equal to,
So y is equal to cos u, and u is equal to 2x plus 3.
and u is equal to 2x plus 3. And what do you want? You want to know dy upon dx.
Yeah.
So how to do that?
So what you do is, so you substitute 2x plus 3 into cos,
There
or
is
for u.
That is another way of doing it. You can also do it separately. Do you know that?
Yeah.
It is equal to, for example, this thing can be written as dy upon du.
Yeah.
And then what should I do right next?
So it would equal to,
No, no.
no, sorry, not 2, sorry, it would equal,
Times, what times?
would it be u cos u?
Sorry, no, no. Look
No.
at the equation which
Oh,
I am
sorry. Oh, yeah. Times du dx.
du dx, yeah, like that. So
Yeah.
that gives, and therefore I was interested that you do this question so that, can you solve this question for me
Sure.
like this?
Yeah. So dy over du is equal to negative sine u.
Yeah. So dy upon du is equal to minus sine u. Yeah. Yeah.
Yeah.
And what do you say? And
And then so du upon dx is equal to 2.
yeah.
Yeah.
So
So
this
then
implies dy upon dx is
equal to negative 2 sine 2x plus 3.
sine, and here we 2x plus 3. Yeah. That could have been done. You were right. So you could have put it there and did that cause, and so that's good. Yeah, that's good. So just I wanted that you understand this. This is called chain rule. So this thing is called this one.
Okay.
So
Yeah, change.
it can be even longer. Yeah. The
Yeah.
chain rule could be dy upon dx, dx upon dy, or and so forth. I mean, you can have this chain rule even like a chain, longer one. Okay,
Yeah.
uh, let's go to the question which you now want, the 55. The question 55. What does question 55 says?
Okay, so 55 says y equals sine x at the point pi over 6.
So this is
Uh,
y is equal to sine x,
yeah.
and we have to find the gradient.
Yeah.
Find gradient. So find. What is a gradient actually in mathematical term,
Gradient is a slope
and how you find that here?
by using the differentiated equation and substituting x value.
Yeah, so this is a gradient. So, and the value was at the point. So what is the point? Pi over 6 comma 1 over 2.
Ah, yeah.
Yeah. So what can you suggest what to do now?
Yeah.
Yeah.
So if we differentiate sine x,
Yeah. So y bar is
cos x,
cos x. So this is your okay. And then
then you substitute in uh, pi over 6.
okay. So you have to find the, so you just y bar, and you want to know this dy upon dx at, okay, so y bar, and you would put what is the value of
Pi over 6.
um yeah, so it is saying find the gradient of each at the, for what is pi over 6.5 comma half. So you are given two values, pi over 6.5.
Yeah, but half is a y value, though, isn't it?
um Pi over 6 comma half. Determine the gradient of each at the following point. Pi over 6.5. Okay. Actually, if I see, it is the pi over 6 comma half. Um, yeah, so it is, but if it is already, then why it should be half? Do you understand? It means at pi over 6. Oh, actually, what is sine pi over 6, by the way? Do you have a calculator?
Yeah, sine over 6. Sure. 0.5.
Yeah, so it is given that this is the point on. Now we want to know its gradient at this point. So actually, if I draw, this is something like this. Yeah,
Yeah.
this is a sine, and you are given that it is at pi over 6, and you want to know. So you would put now x pi over 6. Yeah, so we had this y bar cos. So what would be the answer?
The answer is square root 3 over 2.
Sorry?
Square root 3 over 2?
Yeah, that's the answer. So at the start, do you understand what is the difference? It says at pi over 6, the value is half. Yeah, because if you see, oh, sorry, this is not the sine curve. I drew a cos curve. So this is cos x, and the sine would be something like this. Do you know the difference of them? And this is 90.
Yeah.
This is pi over 2. This is pi. This is 2 pi. Yeah, this is 0.
Yeah.
And it is 2 pi over 3. Yeah.
Yeah.
Okay. And so we were given that at this 90. So we were here and it says the value is this. And what is the slope here? And we found out that the slope is this. Yeah.
Yeah.
Okay. So now what next? And we have done 55 and we can do these others also. I think the good question would be something like 57. Can you solve 57?
Okay, I'll try.
Yeah.
Yeah, I think I got it.
Okay, good. I can just look at the um, answer and see. Uh, this was the question number.
Is it 57?
Okay. So what is the answer?
I think I got 2
Yeah, that's
in
the
the end.
answer. Yeah, that's the
Okay.
answer.
Yeah.
So that's the answer. We So any other question which you want that I should do?
Not really, no.
Okay. We will move to the find the equation of tangent to the curve. I think we have
Okay.
done that, and it's the second. Let's do 63.
Okay.
Let's do 63. So let me write it. plus 63. So equation of the tangent to the curve. We have to find equation to the tangent of the curve. And what is the equation of the curve?
Um, y equals x sine x.
We have to find the equation. How to find that? And at the point,
At the point pi over 2, pi over 2.
okay, at the point is, it is pi over 2 comma pi over 2. Yeah?
Yeah.
So how to do that?
Okay, so first, so differentiate x sine x.
Yeah, okay.
So that gives us x cos x plus sine x.
Okay, we will find first y bar, put it
Yeah,
there, and that would give us the slope. And we have to
yeah.
find the equation. What is an equation of the curve, tangent? First of all, let's ask you that. What is
Equation
a generic?
equals
Yeah, y is equal
y
to
equals mx plus c.
mx plus c. Good. And we will get this m from this equation. So let's find that
Yeah.
m first. Kindly find the m and let me know.
Yep. So the gradient is 1.
Oh, the gradient is 1. Good. That's correct. So let's say how you did that. You have a y bar is equal to sine x plus, and then you have a x, and sine x derivative is cos x. Yeah.
Yeah.
And then you put pi over 2. So pi over 2 sine pi over 2 plus pi over 2 into cos pi over 2. And this thing is 0. Cos pi over 2 is 0.
Yeah.
So this thing becomes y bar becomes sine pi over 2. So we have an equation which is y is equal to control Z. Yeah, y is equal to 1,
X
uh,
plus c.
yeah, x plus c. Now we have to find this value of
C.
c also.
Yeah.
So y is equal to x plus c. So how to find the value of c?
Um. To find c, you substitute substitute the points in back into y equals x plus c.
Uh, which point? Yeah.
Uh, pi over 2 and pi over 2.
Pi over 2 and these pi over 2 are for the sinusoidal or for that equation. These are not for this equation, which is tangent.
Okay.
But we know what we know. Yeah, you are right. In fact, because the equation at at that thing would have the value. I mean, pi over 2, because at this thing, this tangent is coming through this point, which is here.
Yeah.
So pi over
Yeah.
2 over pi over 2 plus c. So
Yeah.
that means c is equal to what?
So that c is equal to 0.
0. And therefore the equation, the final equation which we have of the tangent is y is equal to x. Got it?
Yeah.
Yeah, that's good. That's good. It's Yeah, and there is also a question. Similar question is at 64. We have last 5 minutes, so I don't know whether we should do that or no. But that's good. I think we covered quite a good amount of this, but we can move further. Maybe one question more.
I don't mind. Yeah.
Yeah. So, what do you think would be better? Do you want to do 64 or we move to the next page maybe?
We can do 64.
Okay, let's do the 64. Question number 64 of the. So we have again it's similar. Find tangent to what is the equation? Y is equal to
Y is equal to x plus 3 cos 2x
3 plus cos 2x. Yeah, at point.
at 0, 3.
Yeah. How to do that? You have already done a similar question, so kindly solve it.
Okay. Yeah. So I got for the tangent, I got for the equation, I got y equals x plus 3.
So the tangent equation is y is equal to, yeah, that's correct answer. So
Yeah.
x plus 3. Okay. So we will just finish it now and just a quick recap so that although so a quick recap what we have done today. Uh, we were actually referring to exercise 3A, 7A of Sadler book, Unit 3. Sadler book, Unit 3. So we first of all looked at calculus of trigonometric functions. We said if y is sine x, derivative is cos x. If the function is cos x, the derivative is minus sine x. If it's a tangent x, it is the derivative is 1 over cos square x, which is also called, what is 1 over cos x called?
Sec x.
Yeah, secant. It's called secant. Actually the name is, uh, let me write it because it's written as a sec, but it is secant. C-A-N-T, secant. Okay,
Mm.
and then is a cotangent. So tangent, cotangent. Sine is cosecant. Cosecant, secant, cotangent. Okay, we did a few questions. We looked at first question, which was simple. Then what the second one was u into v, the multiplication formula. Then we also did a question, anti-differentiation, although that is now the next exercise, but you have got some idea of that. We found out that it could be if if a function its derivative and we take its entire derivative, so it would be the function itself. Yeah, and
Yeah.
that sine and cosine, that's something which we did actually. uh, we have I think we did somewhere the functions also, something like this. So this was one of the, here this is a derivative. Okay, we looked at few of the entire derivative questions, and then we also did where there was a power of function, and then we also did something which is called a chain rule. So the chain rule, we did few questions with, and then we attempted a few questions from the exercise. So that was all for today. Do you have any question, please?
No, I have no questions.
Okay,
No.
thank you.